Good day. This is a clear, fact-focused rundown of a pivotal night and its aftermath, told in a straightforward news voiceover style without dramatization or graphic detail. The night began with a sudden flash, ground vibrations, and rising flames on the horizon, a sequence that instantly disoriented multiple armored crews and complicated identification of friend and foe under heavy electronic interference and darkness, a common challenge in modern mechanized operations. In those first moments, commanders faced a basic problem that defines night fighting: confirming sources of fire without reliable visual cues, while radios struggle under jamming and cluttered spectrum conditions. That uncertainty set the stage for a battle where rapid sensing, disciplined procedure, and equipment design mattered more than raw numbers. 2 Leopard main battle tanks absorbed direct frontal hits, yet the crews evacuated alive, a result aligned with Western design priorities that segregate ammunition and vent explosive forces away from crews to preserve survivability after penetration or fire. The incident illustrated a broader engineering divergence. Western vehicles emphasize crew protection through armored bulkheads and blow-off pathways, turning potential total losses into survivable events and maintaining trained personnel for follow-on operations. For ground forces, preserving skilled crews is not just humane policy. It is critical force management that sustains operational tempo after shocks and prevents morale collapse. Nearby, an Abrams integrated drone-fed coordinates, thermal imagery, and a stabilized GPS-linked fire control process to designate and then collapse a fortified position, showing how a single platform functions as a precision node in a broader sensor-to-shooter chain. The sequence highlighted a working method: cue from unmanned reconnaissance, compute a firing solution under movement, and deliver measured effects while communications are degraded by jamming. Precision in this context is as much about data quality and processing as about the gun itself, compressing the cycle from detection to effect into moments that deny adversaries meaningful reaction time. At the tactical edge, the Bradley fighting vehicle joined to protect flanks and manage close threats with stabilized fire and sensors that thrive in debris and narrow angles, offsetting tank blind spots and reaction lag in cluttered terrain. This triad, Leopard for staying power, Abrams for precise effects and data fusion, Bradley for agility and local security, moved as a single system rather than isolated assets. Drones provided real-time visuals, and encrypted communications connected crews that had not trained together extensively, yet still achieved synchronization through common procedures and shared situational products. By first light, that integration stalled a larger armored advance, not by destroying every vehicle, but by disrupting momentum, blinding key nodes, and preventing organized exploitation of breakthroughs. The crucial factor was not a numerical exchange. It was the ability to observe, decide, and act faster with fewer missteps under stress. In modern mechanized engagements, that cycle, observe, orient, decide, act, now runs on a mesh of sensors and disciplined crews. And dominance often comes from shortening the cycle by seconds, not minutes. The fight then shifted toward a damaged town, where armor loses much of its edge, and line-of-sight tools are constrained by corners, smoke, and debris, placing a premium on stealth, angles, and timing. A Bradley waited under cover, sensors live, with a plan to fire, displace, and reappear on a new axis rather than stand in place and trade shots. When a T-72 entered an exposed intersection, the crew executed the sequence in seconds, striking vulnerable side aspects, withdrawing into cover, and re-engaging from a different street to avoid predictable counters. The apparent chaos concealed a wider web of coordination. Observers, drone operators, vehicle crews, and artillery links shared bearings and timing through encrypted channels, while electronic teams degraded hostile links and delayed counterfires. The result was a synchronized response, where a small unit initiated contact, and distributed fires amplified the effect with measured timing. This pattern, local initiative backed by responsive networks, is a hallmark of combined arms under contemporary electronic pressure. On the open steppe, an engagement between a BTR-82A and a Bradley underscored the central shift from raw firepower to processing power and stabilization. The BTR opened with volume fire, but the Bradley's thermal imaging, stabilization, and ballistic computation produced a rapid, accurate response while moving, ending the engagement in a brief interval measured in only a few seconds. Here, the advantage lay in fire control and sensor clarity, not in gun caliber alone. Small first-person view drones have changed the loss calculus for armored forces, striking vulnerable engine decks, roof lines, and turret gaps at a fraction of the cost of missiles or guided artillery. Footage and field reports consistently show low-cost drones neutralizing expensive platforms when defenses are not tuned for small, agile threats, creating a psychological and doctrinal shock for formations long conditioned to think in terms of armor thickness and kinetic exchanges. The message for commanders is consistent. Small, networked precision can displace mass as the primary determinant of who moves and who stalls. Ad hoc protections, such as cage armor and heavy side plating, carry trade-offs, often reducing visibility, stressing drive trains, and trapping blast effects and fragments in ways that can worsen outcomes during overhead or confined space detonations. These improvisations can still be situationally useful, but they seldom solve the underlying exposure to low, fast, precise attacks, approaching from angles not covered by legacy sensors and armor profiles. The trend points toward active protection, integrated sensing, and mobility tactics, rather than purely passive layering. Minefields remain a silent driver of catastrophic losses when underbelly shocks ignite ammunition, especially in designs that place propellant and rounds close to crews in compact turrets and carousels. The physics of a vertical blast under the turret ring need only a brief chain reaction to eject assemblies and render vehicles inoperable while giving crews little time to escape. By contrast, vehicles that isolate ammunition with armored partitions and blow-off panels often allow crews to survive and even save the platform for repair, altering both morale and logistics. The broader doctrine follows the engineering, where crews are protected and trained for decentralized action. Adaptation under fire is faster, and small teams can execute complex sequences without waiting for step-by-step authorization. This approach, often described as mission command, equips officers and non-commissioned leaders to act on intent, not only on orders, compressing the time from contact to effect. In the battles described, that mindset repeatedly converted fleeting windows into tangible results. Operational practice has coalesced into a tank-drone electronic reconnaissance formula. Unmanned systems reconnoiter, electronic teams degrade hostile links and navigation, and armor moves on mapped corridors with pre-planned fire support and recovery measures. This method does not eliminate risk, but it reduces uncertainty to levels crews can manage, keeping assaults from dissolving into uncoordinated pushes that burn time and vehicles. The formula also economizes ammunition by directing heavy fires at confirmed, time-sensitive targets instead of saturating broad areas. Industrial limits shape tactics in visible ways. Older vehicles brought from storage are often asked to perform roles for which they were not designed, especially under persistent drone surveillance and pervasive thermal optics. The return of mid-20th century platforms to frontline tasks signals constrained production and modernization pipelines, which in turn pressures commanders to accept higher risk in contested zones. Those visible losses feed into information effects that influence public perception and unit confidence. Looking forward, Allied concepts envision armored forces that are lighter, more efficient, and more connected. Hybrid electric drives to reduce signatures, active protection systems to intercept threats, and pervasive AI-assisted sensing to identify and prioritize dangers before crews can see them with unaided eyes. In that architecture, tanks serve as decisive, striking elements, guided by a web of overhead and ground-based sensors, rather than as independent hunter-killers. Success will reflect how well humans and machines share workload and timing without saturating crews or ceding judgment completely to automated systems. The practical lesson from the night and the following day is consistent. Information and coordinated action now outrun massed armor used in isolation, and survivability depends on design choices coupled with disciplined, decentralized execution. Crews who train to act within intent and who trust their networks can hold ground against larger formations by breaking their sequence of action at critical points. That is the operational meaning of reaction speed: sensing clearly, deciding quickly, and applying measured force where it changes outcomes instead of trading volume for volume. In urban sectors, the same logic applies, with even less margin for error. The unit that sees first, shoots first, and relocates before the response arrives, controls the tempo and preserves force integrity. Vehicles that combine stabilized fire, thermal sighting, and quick displacement can dismantle attacks piecemeal, provided they coordinate with observers and maintain constant terrain awareness. The voice links and data cues that made the night action coherent also prevent small urban wins from turning into larger losses through overextension. On open ground, engagements increasingly turn on who stabilizes and computes accurately at speed, not who fires first with the largest gun. When platforms integrate thermal clarity with ballistic computation and stable motion, the window from detection to effective fire shrinks below human reaction times unsupported by aids. That technical edge is only decisive when crews are trained to trust their instruments, while maintaining standard checks to avoid fratricide under pressure. The rise of small drones forces a rethinking of protection. Passive armor alone cannot guarantee survival against low, fast, precise threats that exploit seams and rooflines. Active defenses, distributed jamming, deceptive signatures, and mobile tactics become necessary layers that work together rather than as single fixes. The cost imbalance is durable, so countermeasures must emphasize speed, integration, and training rather than solely hardware thickness. For news audiences, the core point is clear and avoids sensationalism. Modern armored warfare is no longer about who fields the most vehicles, but about who senses, decides, and coordinates faster with the least confusion under electronic and physical pressure. The night's events and the urban and open ground engagements that followed offer consistent evidence for that conclusion across different terrains and force mixes. Within platform limitations and policy constraints, crews and commanders have adapted methods that prioritize survivability, precision, and timing over spectacle. As forces plan for coming months and years, programs point toward connected fleets, where tanks, infantry vehicles, uncrewed air and ground sensors, and artillery form a single decision system with human judgment at key points. The intention is to keep crews alive, shorten the time to correct action, and prevent adversaries from resetting after shocks. In that design, training on mission command and disciplined communications is as critical as hardware upgrades. The night that began with confusion ended with a practical demonstration of these trends. Crews lived because of protection design and procedure. Units held because sensing and coordination worked under stress. And attacks failed when they could not close the loop quickly enough to outpace the defense. Those outcomes do not erase the risks or the costs, but they show what changes the balance in a battlefield saturated with drones and electronic effects. For viewers, the takeaway is measured: modern ground combat rewards clarity, discipline, and connected action more than raw mass or isolated heroics.